Hey everyone, my name is Scott, and today we're going to solve the search in a binary search tree problem on LeetCode. This problem is just a classic searching through a binary search tree for a node, for a value problem, except instead of just returning true or false if we found it or not, they want us to return the subtree rooted at that value. So let's say we're given this tree here, and we want to search for 2. Well, obviously 2 is right here, but instead of returning true or false, true obviously that we found 2 here, we're going to return the subtree. And the subtree rooted at 2 is this subtree right here. 2 with 1 is the left child, 3 is the right child. So we return this subtree right here, 2, 1, and 3. If we don't find it, then we should return null. So if they ask us to find 9 in here, we return null, because obviously there is no 9 value in that tree. So like with most tree problems, we're going to solve this problem recursively. So our base case here, what happens if the root is null? Well, if the root is null, obviously whatever value they've asked us to find cannot be in the tree. So we're going to return null, because that's what happens when we cannot find the value we're looking for. Now if the root value is equal to the value we're looking for, then obviously we'll just return the root, because we've found the node with the value we're looking for. We return that root, which will be the root of the tree that is rooted at that value. If the root's value is greater than value, well, this is where we invoke the binary search tree property, okay? Being that in a binary search tree, every node to the left is less than the root, and every node to the right is greater than the root, okay? So if the root's value is greater than the value we're looking for, that means that the value we're looking for, if it exists, has to exist in the left subtree. So we're going to return search BST from the left, and passing in the value to look for. And then probably know what's coming here. If the root's value is less than the value, well, what was that? That must mean that the value that we're looking for, since it's greater than the root, must be in the right subtree. And then down here at the bottom, we have to return something if we miss all these cases. I'm just going to put return null. This doesn't really do anything. We've pretty much covered every possible case in these cases right here. Alright, compiles, looks right. And accepted solution. Alright, cool. So this is just searching through a binary search tree. If you don't know how binary search trees work, that's a big one. Basically, in a binary search tree, you obviously have a root value, and then for each node, every node to your left, every node to your left subtree is less than you are, and then every node to your right is greater than you are. So that's why we're able to invoke that property here to search through this tree. So that is it for this video.